Hello everyone, my name is Bomfim and I'm going to present an educational problem called Hetool, focused on the teach-learning process of the half-edge topological data structure. Topological data structures have been increasingly used to solve engineering problems due to the advantages that these structures offer. The main advantages are efficient, organization and speed, and manage the information of a solved. The Hetool problems aims to teach the basic concepts involving the implementation of the half-edge data structure, which is well known and used. This application was written in Python following the pattern of object-oriented programming. For the development of the graphical interface of the solved model, the XLII library was used. The representation of the visualization of the models was carried out using the Open Graphs library known as OpenGL. The data structure was developed following the MVC pattern that presents three main systems, composed of a model, view, and controller. Half-edge is a topological data structure developed by Mantilla which allows the construction of two-dimensional solids and the information management of these solids. These data structures work through an abstract entity called a half-edge that stores most of the topological information. The half-edge entity originates from the subdivision of a edge into two half-edges that are oriented in opposite directions. Most topological queries are performed using information stored in such an entity. The half-edge data structure is composed of shells, faces, loops, edges, half-edges, and vertices. These topological elements are related according to the hierarchy shown in this image. All these elements are linked together through a linked list. In this data structure, each shell is made up of a set of faces, vertices, and edges. The face is composed of a set of loops. The first loop stored by the face is the outer loop and represents the outer boundary of the face. The other loops of the face are called inner loops and represent the inner boundaries of this face. Each loop is formed by a set of half-edges, and each half-edge stores a vertex and the edge on which that half-edge originated. The half-edge data structure uses operations that modify it. These operations are performed by Euler operators that can be defined as creators and modifiers of the topological data structure. These operators feature the ability to modify the data structure by adding or deleting faces, edges, and vertices. The following table presents the Euler operators implemented in the data structure. Each Euler operator has an inverse operator. Operators are named following a pattern. The acronym N refers to the ability to make, and the acronym K to destroy. The acronym S refers to the ability to split, and the acronym R refers to the creation of an inner loop inside the face. The other acronyms refer to the created entities. For example, the operator A.M.B makes an edge and a vertex, and its inverse operator K.E.V destroys an edge and a vertex. Another example, the M.E.F operator makes an edge and a face, and its inverse operator K.E.F destroys an edge and a face. The meaning of the other operators can be seen in the table. Have these basic concepts about the half-edge data structure in mind, the developed application aims to help teach and learn these concepts in a more dynamic and attractive way. Initially, I will demonstrate some basic functionality of the application, and then I will talk more about the functions related to the topological concepts involving the data structure. The Hetool has a function that generates a grid of points that helps in modeling. After activating the grid, points can be attracted to this grid if the checkbox is marked. The program allows the creation of points, lines, and polylines. Planar regions are automatically generated if there is a set of connect segments. As you can see, the geometric intersections between the created elements are performed automatically. To create a hole, first select a face and then click on the delete button. And to turn it into a face again, just select the hole and then click on this button. As you can see, every modeling action can be undone and redone. The application also has functions that adjust the visualization limits of the model window, such as translation and zoom. The program allows saving and reading models from JSON files. As can be seen, the Hetool can present multiple screens, which allows to model and visualize several solids. From now on, I will show the programming functions related to the topological concepts of the half-edge data structure. The application allows the visualization of the half-edge, which, as explained, is the base of the data structure. From the visualization of the half-edge, it can be seen that every outer loop is oriented counterclockwise. The inner loops of a face are oriented clockwise. With the half-edge visualization active, when selected any entity, it's possible to visualize the topological and geometric formation of the selected entity. When selected a vertex, the program indicates which half-edge is being stored in this vertex and the ID of this half-edge. Likewise, when selected an edge, the application shows all topological and geometric information related to the edge. By selecting a face, we can see the outer loop of the face highlighting blue and the inner loop of this face highlighting orange. Note that there is a half-edge highlighting green inside the outer loop of the face. This half-edge is the half-edge stored by the outer loop of the face and where the navigation between the half-edge of this face starts. As you can see, endpoint segment of face added to a face is an inner loop highlighting orange. If an inner loop is connected to the outer loop of the face, that loop will become part of the outer loop of the face and will be highlighting blue. This application has a box called Euler Operators that demonstrates all the operations used during the modeling process. For example, when the points at the face, the data structure uses the MVR operator, which creates a vertex in the inner loop on the face. When at a segment, the data structure uses the MEV operator that adds an edge and a vector to the model. By adding a segment that crosses a existing segment, the data structure uses the MVSE operator that creates a vertex and splits the existing edges, and then use two MEV operators to add the two vertices and two edges. When creating a set of connect segments, the data structure uses the MEF operator that creates an edge and a new face. If the user performs a modeling action involving more than 8 operators, this box will show only the first 4 and the last 4 operators using this action. As you can see, this educational program, which is still under development, demonstrates the basic function of the half-edge data structure. The Hetool application allows teaching a friendly, sequential, and interactive way the basic concepts present in the half-edge data structure, which is well known and used to solve civil engineering problems. More information about the developed tool can be found in the article. Thank you all for your attention.